Okay guys, today we're doing 4.3 differentiability with variables. So basically there's going to be a variable that you got to find in order to make a function differentiable. Let's get started. Okay, first let's talk about one that we've done in the past. Find the k value that will make the function continuous. So if you just got to find the k value that's going to make this continuous, that means that you just got to set these two things equal to each other, because you want them to have the same value, y value. So you're just going to be doing this, and this is something we've done in the past. And if you notice right now, we have two variables that are missing k and x. So we only have one formula. So there has to be something else we know, and we know that we are trying to find out what's going to make it continuous when x is equal to -2. So we can plug -2 in for the x. So we have k squared plus 6 times -2 equals k times -2 over 2. And then we can just simplify this. So we got k squared minus 12 equals -2 and 2 can cancel, just leaving you with the negative. So negative k. And then what you can do here is you can move over the k, and you can have k squared plus k minus 12 equals 0, leaving you open to factoring and solving for the k values that would make this continuous. So that would be k and k, and we got a +4 and a -3. And then you can just set each one of these equal to 0. You got k equals -4 and k equals 3. And those are the two values that would make this continuous. So you could either plug in a 3 into both of them, those k values, or you could plug in a -4 into both of those k values. And that's going to make this continuous, meaning that it would have a limit as x approaches a -2 of our function. Remember, that's rule 1 for continuity. Rule 2 was it will have a point at -2. And rule 3 is that they would be equal. So the limit as x approaches -2 of our function would equal f of -2. And that's what would make it continuous. Okay, now what we're going to be doing is we're going to be finding the a and the b value that's going to make it differentiable. So if you notice here, remember differentiability is set up to where first it needs to be continuous. And I just showed you how to make a function continuous. So we're going to do the exact same thing here. So let's set these two things equal to each other. Ax squared plus 3 equals bx minus 4. And same thing, we're trying to do that at an x value of -1. So let's plug that in. A -1 squared plus 3 equals b -1 minus 4. We can simplify this. -1 squared is just 1. So we have a plus 3 equals -b minus 4. Okay, and then I'm going to leave it right there. You can move over one of these numbers if you want, one of these constants. I guess let's add the 4 over. So we can have a plus 7 equals -b. And I'll leave it like that. But now, notice we have two variables. We can't solve for a or b. We need another equation that's made up of a and b in order to solve for those. We need to have a system of equations, right? We need to, so we can use substitution. So remember, continuity isn't the only thing that makes up something differentiable. Remember, differentiability doesn't only mean that their y values are the same, but also means that their slopes are the same. So what we're going to do is we're going to set the slopes of these two things equal to each other. And slope means derivative, right? So we're going to need to take the derivative of this and the derivative of this and set those equal to each other. So let's take the derivative of this top one first. That would be bringing the 2 down. Now this is not product rule because a is a constant. A is not a variable. So the derivative of that is going to be 2ax, and derivative of 3 is 0. So equals, let's take the derivative of this side. The derivative of that is just b. So we have these set equal to each other. Now also remember, just like we did over here, we know what x value we're trying to check it at. We're trying to check it at -1. So let's plug that in. -1, and that's going to be, if you multiply these, -2a equals b. Now we have two equations with a and b in it. So we can use substitution in order to solve for a and b. So what you're going to need to do substitution is you either need to solve for a or b on one of these two equations, okay? If you notice on this one, I'm already solved for b. So I'm just going to use this, b equals negative 2a, and I'm going to plug that in for b, okay? So we're going to have a plus 7 equals negative, and for b, I'm going to be plugging in negative 2a. So I'm going to be plugging negative 2a into here. So that's going to leave us with a plus 7 equals 2a. And you just solve for a. So let's subtract this a over. So 7 equals just a. So a is 7. Now we have a. We also need to figure out what b is. Since we now have a, we can plug a right there, and that'll tell us what b is. So b is equal to negative 2a. And remember, a is 7. So I'll just plug that in there. So b is equal to negative 14. And those are the two values that would make this continuous. So if you put a 7 here and a negative 14 here, then this would be a differentiable function. Any other values would make it not differentiable. Okay, I got one more here to do. Now we're going to follow the exact same format that we did on the last one. You're going to try to make them continuous. You're going to try to make them differentiable, which means set them equal to each other, the y values, set the slopes equal to each other, and then use substitution to solve for a and b. So let's do these 3 steps here. First one, ax cubed plus 2 equals b 2x plus 1 squared. Now I'm going to be plugging in an x value of 1 into all this. Okay, so we got a 1 cubed plus 2 equals b 2 times 1 plus 1 squared. Okay, this is going to leave us with a plus 2 equals, this is going to be 2 plus 3 squared, 9b. And I'll leave it like that. I'll just stop right there. Okay. Now let's do the differentiable portion, the slopes. So we're going to set the derivatives equal to each other. 3ax squared, that's the derivative of this top one. Just that, and remember it's not product rule. The 3 comes down, you subtract 1 from the exponent, equals, now this one, this is going to be product rule right here. I mean quotient rule, not product rule. Not quotient rule, chain rule. It's going to be chain rule because we got this thing inside of here. So this 2 is going to come down, multiply with a b, so we're going to get 2b. Leave the inside alone. Subtract 1 from your exponent, so your exponent is going to be 1. I don't need to write that because 1 doesn't do anything. Times the derivative of the inside, and the derivative of the inside, the derivative of 2x is just 2. And now we can plug in 1 for x. So we got 3a 1 squared equals 2b 2 times 1 plus 1 all multiplied by 2. Okay, this is just going to be 3a equals, multiplying all this out, okay, this is going to be 3 right here, times 2 is 6, times 2 is 12b. Okay, I'm going to stop right there. Okay, now I need to use substitution. I need to solve for either a or b on one of these. You're going to try to choose the one that would make it the easiest. I think what would be easiest is solving for a right here. So we're going to divide by 3. So that would give us a is equal to 4b. And then we can use this and there for substitution. Yeah. So let's plug in that 4b for a right there where a is. I'll do that over here. So it'll be 4b plus 2 equals 9b. We're just solving for b. So let's subtract the 4b over. It's going to be 2 equals 5b. So b is equal to 2 over 5. Okay, that's what b is. Now we can come over here and plug b into here, and we got what a is. So a is equal to 4b. b is 2 over 5, so we got 4 times 2 over 5, and that's going to leave us with a is 8 over 5. And those are the a and b values that make this function differentiable. Remember, there's always 3 steps. The continuous portion, where you set them equal to each other. the differentiable portion where you set their derivatives equal to each other, the substitution portion where you solve for a and b. And that's how you do all these.